And happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so I heard from two different students about the same specific problem. This is from section 11.2, number 19. And I didn't check to see if they're the same numbers, but we'll do one and then we'll look at the other one. And if the numbers are different, we'll do that one as well. So it says the following function is 1-to-1, and that function is f of x equals 5 divided by the quantity x minus 9. It says find the inverse of the function and express it using f inverse of x notation. All right, so 4 steps. Step number 1, replace f of x with y. So y equals 5 divided by x minus 9. Step number 2, interchange x and y. So x equals 5 times y, 5 divided by the quantity y minus 9. Well, now we got to get y by itself, but y is in the denominator and it's not by itself there. So the next move is going to be to multiply both sides by the least common denominator, which is y minus 9. So now on the left side, I have y minus 9 times x. On the right side, I have 5. Well, there's a couple of different ways I can go. I can distribute or I can not distribute. I'm going to not distribute. Let's see what that would look like. So the next step would be to divide both sides by x. So now I'll have y minus 9 equals 5 over x. The next step would be to add 9. So y equals 5 over x plus 9. And finally, f inverse of x equals 5 over x plus 9. All right. Do you want me to go back and do it the way where you distribute? Or do you care?
No, this way is the way I was trying to do it.
Okay, all right. Good. I'm going to go ahead now and look at the other person's example to see if the numbers are different. Let's see here. 47, 80. There. 11.2. Number 19. It's slightly different. We'll do that one. So this again is 11.2, number 9, but a different version. It says f of x equals 3 over the quantity x minus 5. It's going to be very, very similar. So our first step is to replace f of x with y. So we get y equals 3 over the quantity x minus 5. Our next step is to interchange x and y. So x equals 3 divided by y minus 5. Our next step is going to be to multiply both sides by the least common denominator. So now we've got y minus 5, the quantity, times x equals 3. Divide both sides by x. Y minus 5 equals 3 over x. Add 5 to both sides. Y equals 3 over x plus 5. Use f of x, f inverse of x function notation equals 3 over x plus 5. And there you have it. Okay, any other questions before we go on? Alrighty. Let's see here. I'm going to switch screens now. Maybe. We're going to be doing some graphing. And let me find the document. Okay. And let's make sure I'm sharing the right thing. So can you see the screen with the graph on it?
Yes.
Okay, great. We have looked at linear equations. For instance, y equals 2x, the graph of which would be what? A straight line. Okay. We've looked at quadratic or second degree equations like y equals x squared, the graph of which would be a parabola. I know these are lovely graphs. Now we're going to be looking at what are called exponential equations or exponential functions. And those are of the form where the variable is the exponent. So for instance, y equals 2 to the x power. And what I want to do is go back here and let's start over with just y equals 2 to the x power. And let's make a table with some values and plot it and see what it looks like. Okay. Now, you don't have to use these numbers, but whenever I'm starting a new graph and I'm not really sure, what to do till I kind of get used to it, I like to just start with -3 to +3. That may not always be good first choices, but I can try those. And if those aren't good, then I can experiment from there. But we're going to do a little review of back in chapter 5, rules of exponents, and we kind of reviewed them some in chapter 9 as well. If x is -3, I have y equals 2 to the -3 power. But recall that's 1 over 2 to the +3 power. Writing the base, the reciprocal of the base changes the sign of the exponent. So this is 1 over 8. You okay with that? We'll assume yes then. If x is -2, y equals 2 to the -2 power, which is 1 over 2 to the +2 power, which is 1/4. If x is -1, y equals 2 to the -1 power, which is 1 over 2 to the +1, which is 1/2. If x is 0, y equals 2 to the 0 power. Any number other than 0 raised to the 0 power always equals 1. If x is 1, y equals 2 to the 1 power, which is 2. If x is 2, y equals 2 squared, which is 4. If x is 3, y equals 2 cubed, which is 8. Okay. Any question how I got those values? So now we're going to plot those points. -3 1/8 is about there. -2 1/4 is about there. -1 1/2 about there. And then 0 1, 1 2, 2 4, 3 8. And so this picture I get, I don't know if my graphing tool will fit into that shape or not. Close, but not quite. So I'm just gonna, I've got this plastic shape thing I use to draw graphs, but okay. So there's the graph of y equals 2 to the x power. All right. This is an exponential equation. Let's take a look at some of its characteristics. The domain is all real numbers because this thing continues on to the left. This thing, as it's going up, continues on to the right. The range, let's see, let's write this. So the domain is all real numbers. So from -infinity to infinity. The range would be greater than 0, because as we continue to the left, if we used x as -4, -5, -6, it would keep cutting things in half, but it would never get to 0. In fact, can you see as x gets larger, it doubles, y doubles. As x gets smaller, y gets cut in half. Okay. To the right, this thing is going to continue to go up. So the range is from 0 to infinity, not including 0. There's no x-intercepts because it doesn't cut across the x-axis, but the y-intercept is at what, 0, 1, because anything other than 0 to the 0 power is going to be 1. Okay. We also say that this thing is increasing over its entire domain, going from left to right. As x gets larger, y gets larger. Any questions about that? Okay. Let's see here. What I want to do now is go back here and let's graph a second graph on that same grid. Let me get rid of those things I circled there just a bit. Okay, anyway, now let's go back and let's look at y equals 3 to the x power. Okay, and I'm going to put in the same x values and we'll see what we get for y values. -3, -2, -1, 0, 1, 2, and 3. If x is -3, y equals 3 to the -3 power, which is 1 over 3 to the +3 power, which is 1 over 27. If x is -2, y equals 3 to the -2 power, which is 1 over 3 squared, which is 1/9. If x equals -1, y equals 3 to the -1, which is 1 over 3 to the 1, which is 1/3. If x is 0, y equals 3 to the 0 power, which is 1. If x is 1, y equals 3 to the 1, which is 3. Y equals 3 squared is 9, and 3 cubed is 27. Okay, so the y equals 2 to the x, things were doubling. What are they doing here in y equals 3 to the x? What's going on here? Y is tripling. Okay. Also notice there is, in fact, let's go back to this first one. I should have pointed this out before. There's this reciprocal situation going on. Same thing here. There's this reciprocal situation going on. Okay, now let's graph y equals 3 to the x. So we're at -1/27 and 1/9 and 1/3 and then 1 and then 3 and then 9 and then off the graph, all right? But do you see how on the right side of the y-axis, or on the positive side of the x-axis, this thing is growing faster because instead of doubling, it's tripling? What do you think, let's say y equals 5 to the x. What would that look like? Would the graph be over to the right of the black graph or to the left of the red graph? What do you think?
The left.
Yeah, because it'd be, instead of doubling or tripling, it'd be what, tripling? I don't know, fiving with, let's see, I'm not sure how you'd say that, but anyway, yeah. So you'd have 0, 1, and then you'd have 1, 5 to 25. This thing would grow even more rapidly, right? Okay. Now let's go back and let's look at, let's see here. Let's do this in green. Y equals 1/2 to the x power. Okay. And again, we'll use -3 to +3. Now, if x is -3, y equals 1/2 to the -3 power, which is 2 over 1 to the +3 power, which is 2 cubed or 8. If x is -2, y equals 1/2 to the -2 power, which is 2 over 1 to the 2 power, which is 2 squared, which is 4. If x equals -1, y equals 1/2 to the -1 power, which is 2 over 1 to the 1, which is 2 to the 1, or just 2. What's happening now? Instead of doubling, what are the y values doing? What's going on here? They're cutting in half, aren't they? So this would be 1, a half, a fourth, an eighth. Oh, look at these values compared to those. They're just switched around, aren't they? So what does that graph look like? -3, 8, -2, 4, -1, 2, 0, 1, a half, a fourth, an eighth. So this graph, okay, so let's get rid of that red graph for the moment. For the most part anyway. Okay, so can you see that the green graph is a reflection of the black graph through the y-axis? So this was 2 to the x, and this was 1/2 to the x. Let's look at its characteristics, the green graph. Well, the domain's all real numbers. The range is greater than 0. There's no x-intercepts. The y-intercept is at 1. Those are all the same thing as 2 to the x. But instead of it increasing, it's decreasing over its entire domain. Okay. Now, let's see, how are we doing? We got time. I want to look at 2 more examples of graphs. And let's see here. Let's go back and use red again. Let's look at y equals 1 to the x. Okay, let's see what that looks like. If x is -3, so y equals 1 to the -3 power, which would be 1 over 1 to the 3rd power, which would be 1 over 1, which is 1. If x is -2, y equals 1 to the -2 power, which is 1 over 1 to the +2 power, which is 1 over 1, which is 1. If x is -1, y equals 1 to the -1 power, which is 1 over 1 to the 1 power, which is 1 over 1, which is 1. If x is 0, y equals 1 to the 0 power, which is 1. If x is 1, y equals 1 to the 1, which is 1. If x is 2, y equals 1 squared, which is 1. 1 cubed is 1. So what happens here? What do I get? Well, no matter what x is, y is 1. So we get this horizontal line. Well, that doesn't look at all like those other functions, does it? No. Which is why we throw this one out. And we say that the base can't be 1. So this number here can't be a 1, because then it doesn't behave like an exponential equation or exponential function is supposed to behave. All right, one more example here. Okay. So we'll get rid of all of this again. Now let's see. We'll stick with red again. Now, actually, let's go blue. How about this? Y equals -2 to the x power. Now, that's not this. In that case, the base is 2, and then you apply the negative later. That's not what we're doing. Here, the base is -2, okay, the one that we're looking at. So if x is -3, y equals -2 to the -3 power, which is 1 over -2 to the 3rd power, which is 1 over -8, which is -1/8. Okay, and I know I'm going through the calculations quickly. It's because that's not my point. My point is to get the results to see what it's doing. Okay. If x is -2, y equals -2, the quantity to the -2 power, which is 1 over -2 to the 2 power, which is 1 over 4. Oh, the sign changed, didn't it? If x is -1, y equals -2 to the -1 power, which is 1 over -2 to the 1 power, which is 1 over -2, which is -1/2. The sign changed again. If x is 0, y equals -2 to the 0 power, which is 1. If x is 1, y equals -2 to the 1 power, which is -2. If x is 2, y equals -2 to the 2 power, which is 4. And then -2 cubed is -8. So as x goes up, y is going back and forth between negative and positive signs. Okay, so how's that going to look? Well, let's see here. Let's get rid of some of this stuff here. Give you enough of it to kind of see what's happening. Okay. What was this blue? So at -3, we're at -1/8. At -2, we're at 1/4. At -1, we're at -1/2. At 0, it's at 1. At 1, it's at -2. At 2, it's at 4. At 3, it's at -8. So this thing's going all over the place. And those are just using integers. Turns out you can't graph it. It doesn't work. In fact, if you plug it into a graphing calculator, it just sits there and spins for a while till it gives up on you. All right, so where are we at? Here's where we're at. Ooh, what was that? Oh, well, an exponential equation is in the form y equals b to the x. B has to be greater than 0, and b cannot equal 1. Okay, so the base has to be positive, because we just looked at what happens when it's negative. If it's 1, we get a straight line. And the following: if b is greater than 0, the graph increases over its entire domain. If b is less than 0, the graph decreases over its entire domain. The domain is all real numbers. The range is greater than 0. There's no x-intercepts, and the y-intercept is at 0, 1 for equations of this form under these conditions. Okay, so those are exponential equations. All right, now let's go back to parabolas, back to chapter 10, and we had something of the form y equals a times x minus h squared plus k, and k moved the graph up or down, and h moved the graph left or right, and a, if a was negative, it opened down. If a was positive, it opened up, all of that stuff. Okay. All of those shifts and flips and all that also work with exponential equations or exponential functions. Let's see what happens here. Let's go to the next one. If I had the graph of y equals 2 to the x, okay, and I'm just going to put some points in here. What about the graph of y equals 2 to the x plus 3? That's going to take the black graph, so this, and it's going to move the whole thing up 3 units. Okay, so instead of the y-intercept being at 0, 1, it would be at 0, 4. Every one of these points would get moved up 1, 2, 3, so it's going to look like that kind of thing, and that's just a rough sketch. What if it was y equals 2 to the x minus 5? Well, everything, let's see, 1, 2, 3, 4, would move down here. Okay, everything would move down 5. What if I had y equals 2 to the x plus 1, where the plus 1 is part of the exponent? Well, in the quadratic equations, inside where the variable was, it moved the inverse direction. So a +1 would have moved it to the left. Same thing's true with this. That's going to move this, if let's say this is y is 2 to the x, it's going to move it that way 1 unit, or y equals 2 to the x minus 3, not 2 to the x, then a minus 3 out here, but a minus 3 as part of the exponent is going to move it that way 3 units. Well, what if you put a negative sign in front of it? Okay, y equals negative 2 to the x. The base is still 2, but the negative sign would flip it over and it would open down like that. Okay? All right. That's all I want to say about the graphing. I want to look at some examples of application problems. Okay, so let's see here. How are we doing? I'm going to go back to my other board, to my whiteboard here. Give me just a minute. And okay, so y equals 2 to the x. What if I had y equals 3 times 2 to the x? Would that be 6 to the x, or would that be 2 to the x and then times 3? Order of operations, you would do 2 to the x times 3. So that, if I went back here and made a table of values, -3, what is this? -1/8, -2, -1/4, -1, -1/2, 0, 1, 1, 2, 2, 4, 3, 8. And then I was going to graph this thing. What would that 3 do? Wouldn't it triple those y values? Because you do 2 to the x, which would give you that. So this is going to be -3/8, -3/4, -3/2, 3, 6, 12, 24. Okay. So this would get multiplied by the 2 to the x. All right. Now, let's say I have this. I have y equals 4 times 0.7 to the t power. Okay. And t stands for time. All right. At the beginning of time for this problem, when t is 0, what is y? How much is there at the beginning of time? In fact, here, let's write it as a function. Let's go y of t equals 4 times 0.7 to the t power. Okay, so in other words, what is y of 0 equal to? Well, what's 0.7 to the 0 power? That would be 1, and that times 4 would be 4. Okay, so the starting value for this problem would be 4 if t is 0. But as time goes on, is this going to increase or decrease? It's going to decrease because the exponential part of the problem, the base, is 0.7, which is between 0 and 1. You know, I just thought about something here that I think I wrote incorrectly. Maybe not, but let me look. I think this is okay. If I have this, we say that the domain is all real numbers and the range is greater than 0, and the y-intercept was at 0, 1. And then I think I said b is greater than 0, and this thing increases. And I think I said b is less than 0. And what I should have said is b is between 0 and 1. Yeah, I think I made that mistake earlier. Okay, if b is less than 0, this thing, it doesn't work. So I want to correct that in case I made that mistake earlier. All right. So back here, At the beginning of time, we've got a 4, but as time goes on, it's going to decrease because our base is between 0 and 1. All right. Let's take a look at this thing. It says A equals 500 times 2/3 to the t power, where t is measured in years. Find the amount present in 10 years. Okay. First of all, how much is there at the beginning of time? So if,
500.
what's that?
500.
Right, 500, because that would be that which is that, right? Now, over time, is the 500 going to increase or decrease?
Decrease.
Because the base is between 0 and 1. Good. Now, it says, what amount is present after 10 years? So A equals 500 times 2/3 to the 10th power. So on our handy dandy calculator, 500 times parentheses 2 divided by 3, close that up, raised to the 10th power, and I get 8.67076. Let's see, what do they want us to do? They round to the nearest 10th, so that would be what? 8.7. Okay. All right, now, let's see here. This says population growth. The population of North Rivers is decreasing exponentially according to the formula P equals 3,745 times 0.93 to the t power, where t is measured in years from the present date. Find the population in 6 years, 9 months. So t is going to be 6 years, 9 months. Okay, before we answer their question, at the beginning of time for this problem, when t is 0, what is the population of North Rivers?
3,745.
Excellent. Is the population growing or decaying? Is it getting larger or smaller?
It's getting smaller.
How do you know, besides it told you?
Because it's between, the base is between 0 and 1.
Excellent. Now, here's the Jeopardy bonus question. At what rate or at what percent is this thing decreasing per year? Be careful.
9.3%.
No.
93%.
Okay. As each year goes by, the next year it's going to be 93% of what it was, because we're going to take it times 0.93 again. So at what rate is it decreasing? 7%.
Oh.
You see it?
Yeah.
Yeah, because that's 93%. So we've got a population. We take 93% of that, we get the new population. We've lost 7%. Okay. Now, we want to find the population after 6 years, 9 months. So converting 6 years, 9 months into years, that would be 6 point what years? What?
6.3.
Go ahead, what?
I don't know.
Okay, 9 months is what fraction of a year?
Oh, 3/4.
Right. So as a decimal, what would it be?
7.5.
There you go, 6.75. Excellent. Okay. So P is 3745 times 0.93 to the 6.75 power. So let's see what we get. 3745 parentheses 0.93, close it up, raised to the 6.75 power. And I get 2294.6, so approximately 2,295 people. Okay. Now, we're going to look at a compound interest formula. So A equals P times the quantity 1 plus R divided by K raised to the K times T power. Okay, P is the initial investment or the principal. R is the interest rate, and that's typically per year. K is the number of compoundings per year, and T is time in years. Now, what do I mean by the number of compoundings? Let's say that a bank pays you a certain rate of interest, but they compound it yearly. So at the end of every year, they calculate the interest, okay? And then that interest stays in the account. But let's say they compound it semi-annually, then K would be 2, twice a year. Quarterly, K would be 4. Monthly, K would be, don't have 12 fingers, okay? Now, this says an initial deposit of $10,000 earns 8% interest. We're going to convert that into a decimal. Compounded quarterly, so that's 4 times a year. How much will be in the account after 10 years? So A is the unknown, the accumulated amount, the amount in the account at the end. We're going to invest $10,000. It pays 8% compounded quarterly. So 4 times a year for 10 years. So what do we get? A equals $10,000, 1 plus 0.08 divided by 4, all raised to the 4 times 10 years. Now, you can put that all in your calculator just like it is, or you can simplify things, but don't round anything off. For instance, 4 times 10 is 40. Not a problem. 0.08 divided by 4 would be 0.02. 1 plus 0.02 would be 1.02. So this particular problem lends itself well to rewriting the whole thing as 10,000, 1.02 to the 40th power. Okay, again, 4 times 10 is 40. 0.08 divided by 4 would be 0.02, 1 plus that, etc., etc. Okay, but let's say that this number doesn't divide out to a nice number. You don't want to round off. So if it ends up giving you some repeated or just ugly number, you got to stick with the whole thing. So if we were going to do that, sticking with the whole thing, you'd put it in the calculator this way: 10,000 parentheses 1 plus 0.08 divided by 4, close parentheses, then the little power or caret key, parentheses 4 times 10, close parentheses, equals. Okay, if you have your calculator with you, I suggest you try this just to make sure that it's working. And I come up with $22,080, and then it's 0.396, etc. But rounding to the nearest cent, which would be the 9, that would round up. So you'd get $22,080 and a whopping 40 cents. All right, any calculator questions on that?
No.
Okay, let's see, how are we doing? We've still got some time. Take a look at this problem. It says comparing interest rates. How much more interest could $1,000 earn in 5 years, compounded quarterly, if the annual interest rate is 5.5% instead of 5%? Okay, so we're going to use this formula A equals P times 1 plus R over K to the KT power. In the first scenario, the principal is $1,000. The time is 5 years. The compounding is quarterly, so that's 4. And the annual interest rate is 5%, so 0.05. Okay. In the second scenario, the principal is also $1,000. The time is also 5 years. The compounding is quarterly, but the interest rate is 5.5%, which would be 0.055. Okay. Let me clean this up a little bit here. Because this would be what, 5.5. So that's how you get 0.055. Okay. So let's take the first scenario. A equals $1,000 times 1 plus 0.05 over 4 raised to the 4 times 5 power. Now, that comes out nice if you simplify it, but I'm just going to leave it. So 1,000 times 1 plus 0.05 divided by 4, close that up, raise it to the power of 4 times 5, and I get $1,282.03.7. So that's going to round up to $1,282.04, okay? Because we came out 0.037. Now let's do the second one. A is $1,000 times 1 plus 0.055 over 4. Oops, to the, I keep wanting to make that into an A instead of just a little caret. Okay, and that's what, 4 times 5 power. So 1,000 parentheses 1 plus 0.055 divided by 4, close it up, raise it to the power 4 times 5, and I get 1314.066, which is going to round up to 1314.7. So how much more money did we make by raising the interest rate 0.5%? 1314.07 minus 1282.04, $32.03. Now, that may not seem like much, but you invest the same amount of money for the same amount of time at the, but the interest rate a little bit higher. So if you're comparing investments, you know, you could make more money on the higher rate of interest. Okay. One last problem. If $1 had been invested on July 4th, 1776, at 5% interest compounded annually, what would it be worth on July 4th, 2076? Okay, so the initial investment is $1. The interest rate is 5%, which is 0.05. It's compounded annually, so K is just 1. From July 4th to 1776 to July 4th to 2076 would be 300 years. Okay, so A equals $1 times 1 plus 0.05 over 1 to the 1 times 300 years. Well, 0.05 divided by 1 is 0.05, right? And 1 plus that would be this, and then 1 times 300. So basically, I've got 1 times 1.05 to the 300th power. Well, if I take 1.05 and raise it to the 300th power, and then take that times 1, I get 996.129. So 2273996.13. So to the nearest cent, $2,273,996.13. And with that, I bid you adieu. So over the weekend, you've got section 11.3 to do. And with that, I'll stop the recording and